This atmosphere consists of different layer of gases. That is the troposphere, stratosphere, mesosphere and thermosphere, and then comes the exosphere. This, in each and every sphere, with the change in the height, the density of gas will be different, and also the temperature in each and every sphere will be different. Got it? So, the troposphere, actually, the term troposphere will means change. So, most of the basic phenomenon, that is like change in the climate, change in the weather, will take place in the troposphere. And one of the most important thing, the formation of cloud to take place over the troposphere. Mostly here, the small aircraft flies over here. The small aircraft, okay, and like here, the troposphere. In troposphere, the more you go towards the sea level, the more warmer it will be. The more you go up above the troposphere, the more colder you will feel. Like I mean to say, in the lower layer of the troposphere, the temperature, or you can say the density of gas will be very high, and it leads to the warmer in the temperature. But the more you move above 160 meters above sea level on the troposphere, there is fall in 1 degree Celsius, and that is known as lapse rate. And see, here, troposphere, in each and every place, it is not same. That means, this is Earth, and if this is equator, okay, basically, sun constantly heat over the belt which lies ranging between equator, subtropical region. Okay, that means I mean to say, Earth mostly hits over the Tropic of Cancer, equator and Tropic of Capricorn. That means the radiation, the insolation, the term insolation refers to the amount of heat received by the Earth. The heat which Earth receives is maximum over this region. Okay, that is over 23.5 degree north, 23.5 degree south. Okay, that means this over the equator, even because of the insulation provided by the sun, the gas also gets warmer. The gas also gets warmer, and you know that the warm gas, it blows up. Okay, it flies up. So here it produces the low pressure. So that's the reason over the equator, the height of the troposphere is higher as compared to the height on the pole. Because on the pole, what happens is, in the North Pole and South Pole, what happens is the insolation of the sun will be very fragmented. That means the insolation of the sun will be not too high. That means here it will be a colder place. This Arctic Circle and this Antarctic Circle, and here the layer of gas, that means here it will be a low pressure. Because of this, here the density of gas will be very high. So that's the reason over the pole, the height of the troposphere is less. That is, we can say it is only 8 kilometers. And on an average, the height of the troposphere will range from 0 to 12 kilometers. Okay, and the temperature, it ranges from 5 degrees Celsius to minus 53 degrees Celsius. And see, basically in a troposphere, there contains a variety of various gases which is very essential for the humankind. It is very essential for humankind, like H2O, which is in terms of gas. Matlab, water vapor is present here, CO2 is present here, N2 is present here, and many more gases are present over the troposphere. And obviously, dust particle is also present here. Okay. Now, see, CO2, as I have discussed earlier also, CO2 is a greenhouse gas, and even this H2O is also a greenhouse gas which keeps the Earth's surface warmer during the night time also. because it has this greenhouse gas has the ability to trap the sun's ray. Okay, and also we should not forget that mostly 80% of the Earth's atmospheric mass is just confined over the troposphere. 80%. Okay, and the more you go towards the sea level, the more the density of the area it will be. So we can say that on an average, approximately over 5.6 kilometers, the percentage of atmospheric mass is around 50%. Make sure it is just an approximate. It might change. It might vary from place to place. Okay. Now let us discuss about the tropopause. Let us discuss about the tropopause. Now the place where the troposphere ends, from there the troposphere begins. From the where the troposphere ends, from there the tropopause it begins. Now I would like to discuss about the stratosphere. The stratosphere is one of the important layer, and it is the second layer after the troposphere. As soon as troposphere ends, troposphere comes, tropopause comes, and then the stratosphere. And the stratosphere is the layer over which the aeroplane, the commercial aeroplane, it flies, and even the jet, it flies. And troposphere plays also very important phenomenon because it has one of the important gas, that is ozone layer, and also it contains N2 and also it contains O2. Okay, we know that ozone layer is a protective blanket which protects us from the ultraviolet rays which is coming up from the sun. So it is very important. And make sure that most of the greenhouse causing gases like CFC, CO2, it accumulates over this layer and it leads to the depletion of the ozone layer, which is very dangerous for the mankind. Now, basically, sorry, not here. It should be written here. 3 and 2 and 4. Okay. Now, basically, troposphere. It starts roughly from 12 km to 50 km. See, from 12 km to 50 km. But one thing we have to keep into mind, that over the stratosphere the temperature will increase. As we have saw in the troposphere, the temperature will decrease, but in a troposphere the temperature will increase. That is roughly, we can say that roughly on an average, approximately from 60 degrees Celsius, it will rise to -2 degrees Celsius. Okay. Now comes the tropopause, a stratopause. The stratopause is a layer which divides the mesosphere and the stratosphere. It is also roughly around between 50 kilometers. Now let us discuss about the mesosphere, which is exactly starts from where the stratopause ends. That is, it goes from about approximately from 50 kilometer till 80 kilometer. It flies up above 18 kilometer, and this is the third lowest layer of atmosphere. This is the third lowest layer of atmosphere where the temperature will again now reduce. That is, we can say roughly from -2 to -92 degrees Celsius, or we can say 100 degrees Celsius. And here basically the charged particles are present here. The charged particles are present here, and some of the water vapor also present here. And since here it is too cold, the water vapor, some of the water vapor, it condenses into cloud, and it is only visible through our naked eye during the bright day, or we can say the sunny day. Otherwise it is not visible. And here in the mesosphere the aircrafts cannot fly, and it is just power to the rockets and all. Rockets. Okay, here the aircrafts will not be able to fly up. Now, as soon as the mesosphere ends, mesopause it enters. Now, let us talk about the thermosphere. In thermosphere, like it is called a thermosphere because it is the warmest place on Earth, and it is called a mesosphere because it is the coldest place in Earth where the temperature approximately reaches 100 degrees Celsius. So similarly here, the height of the thermopause, it goes till 700 kilometer. But it is not just confined to 700 kilometer. It may changes on due to the change in the temperature of the earth. That is, if the sun will be closest to the earth, the height will be higher. If the sun will be farthest from the earth, the height will be lowest. Okay, it can reach up to 1000 kilometer. Now see, some of the, like here, not some of the, here, like say thermosphere. On a thermosphere, the temperature, it rises from minus 92 degrees Celsius to 1500 degrees Celsius. It is very high, hot. It is hot due to the presence of the charged particles like N2 positive, O2 positive and all. Okay, due to the presence of the charged particle, here the temperature of the thermosphere, it's very high. So because the temperature is very high, that's why it is referred to as thermosphere. Now see, this charged particle, it provides a natural light. You can say there is an interaction of this charged particle, due to which there is a natural electrical light. It can be produced on this up above the sky, and for your concise, here you won't be able to find any cloud here. You will see a natural light over here, and that is referred to as aurora borealis, a natural light over the sky due to the charged particle, due to the attraction of charged particle. That is aurora borealis and australis. Aurora borealis and australis. This aurora borealis and australis, the main difference between these two is this has been produced over the northern hemisphere, and this is on the southern hemisphere. That means this aurora borealis is produced over the Arctic Circle, and this aurora australis is produced over the Antarctic Circle. Now, and we can say over the ionosphere, basically whichever satellite message has been transmitted will reflect back from the ionosphere, and it comes back to the earth. That means ionosphere is responsible for transmitting the radio signals. And now this is done about the thermosphere. After thermosphere, there comes a thermopause, and then comes the exosphere with the satellite. That means exosphere means the end of the atmosphere, and it will keep on going until 10,000 kilometers. And this is the topmost layer of the atmosphere, where the atmosphere will meet the space. So I hope you will understood regarding this all. So please copy down this all on your copy, and you will be okay with you. If suppose you did not understand anything, then you can comment on the comment section box. Okay, thank you.